So now, if we are talking about the ICT in industry, we definitely need to talk about the Industry 4.0. The Industry 4.0, and we will talk about the industrial evolution, the fourth industrial revolution, the building blocks of Industry 4.0, the potential industry products implications, the potential consumer products implications, and impact of the industrial revolution or Industry 4.0. And if we will take a look at the next slide, what do you see? The principal element of milling construction that can bring the flow. And the second slide, you will see the change when people organize their efforts to use their power of water or a wind to make a windmill or a water mill. So they organized their efforts in such a way to make it more profitable. The second slide shows that they have organized the usage of the electricity to bring more profit from the business process. And the next slide, you can see the combination of the electrical unit for milling process that work in an organized way and can bring the huge leap in the production. And industrial revolution, if you will take a look, have begun in 18th century by introduction of the mechanical production elements. And the second industrial revolution, beginning of the 20th century, was the introduction of the mass product or lines powered by electric energy. And third industrial revolution was by the help of the computing systems that were incorporated within the production lines. And the fourth industrial revolution is based on the cyber-physical systems. And if you will take a look at this slide, the complexity of the organization of all of the distributed elements and computing elements here grows tremendously. And the phase of early three industrial revolution, you can see here as the stage of the ushered in mechanical production, railways and steam engines in 1870 through 1940, the mass product electricity, and 1960 through 2010, the computers, the usage of the computers, the semiconductors, mainframe computing, and personal devices, and also the internet have brought all of the elements that have made a huge development of the production and industry evolution. And Industry 4.0 in Germany can be like smart factory leadership coalition in USA, and the collective term of technological and concepts of value chain organization, and builds on the digital revolution. The smaller powerful sensors are already used, the machine learning algorithms that are incorporated in the production, the ubiquitous internet that brings the connectivity through all of the devices that are located in the vast area, and the artificial intelligence algorithms that make help to produce decisions with usage of a human and without. And labor and energy costs have tremendously dropped down by usage of the information and communication technology. The elements that even didn't exist in 2006, you can see on the next slide, like iPhone and iPod systems, the Kindle, the 4G network, it didn't exist, the Uber corporation, the Airbnb, Android, and the Oculus Rift, Instagram, the Snapchat, WhatsApp, all of them have not even been invented in 2006. So that means that the speed of the evolution of the industry by the help of the information communication technology increases tremendously. And time to reach the 100 million customers, for example, for the telephony system, it took the 75 years. For the World Wide Web, it took 7 years. For the Facebook social network, it took only 4 years to reach 100 million people. And for Instagram, it took only 2 years. And for a Pokemon game that was very popular in the previous year, it took only 1 month to spread its population to 100 million people. And what is the cyber physical system? The cyber physical system is the combination of the communication, the computation, and the control, so that we can bring the distributed computation system to work together to organize the industrial processes. And for now, the factory have transformed tremendously if they have been using the information communication technology just partly in the business. Now they would like to inform of 100% usage of the computing system with elimination of a human labor. And the 6 design principles of the Industry 4.0 are next. So it is interoperability, the ability of the cyber physical system, humans and smart factories to connect and communicate with each other via Internet of Things and Internet of Services. The virtualization, a virtual copy of the smart factory, the decentralization, the ability of cyber physical system within smart factories to make decisions on their own, the real-time capability, to collect, analyze data and provide the insights immediately, the service orientation, offering of services via the internet, and modularity, the flexibility adaptation of smart factories for changing requirements of individual models. The building blocks of the Industry 4.0 are depicted on the next slide, so that it is very important here to incorporate all of the achievements we have already gained from artificial intelligence, from machine learning, from the operational with the big data, and many other improvements in the connectivity and the internet. They impact all aspects of value chain, the Industry 4.0, from the huge impact to the less impact, and also it will have impact on the human incorporation in all of the business processes that already exist. The digital enterprise can be in the form of the virtual and augmented reality, so that the corporation can be spread worldwide without any necessity to be located in one building or even in one city. The potential implication of the Industry 4.0 are the robot-assisted production, the predictive maintenance, the additive manufacturing of complex parts, the machines as a service, the big data drive quality control, the production online simulation, the smart supply network, and the work. And if we'll take a look at the next slide, we can see that Amazon Corporation, that is incorporated with the distribution of products and big warehouses, they use the robots. And from 2013 up to 2016, the number of robots increased 10 times from the beginning of the initial process. The Siemens Corporation, they now use the elements of the Industry 4.0 that can improve the technological process that could take 1 or 2 days up to 1 hour by usage of the artificial intelligence and machine learning algorithms. The Trump system, the German toolmaker, an Industry 4.0 supplier and worldwide maker leader of laser system, has put the first social machines to work. Each component is smart and knows what work has already been carried out on it. Because the production facility already knows its capacity of utilization and communicates with other facility, production options are automatically optimized. The General Electric uses the Industry 4.0 in such a way to improve the prediction elements in their business processes. And if we'll take a look at the next slide, you will see a very interesting examples of the Industry 4.0 implications, like Philips lighting, where we can control the lighting bulb by using our mobile devices, by dimming the light or switching or turning off or on. The Medtronic corporation that can bring the internal part of the sugar measurement element in our blood that can automatically signal of the exhausting values. The Ralph Lauren corporation that manufacture the dress, they incorporate the smart dress that can help you to control your heat and other parameters, and by analyzing this, they can suggest you a better way of making physical trainings. The Babolat, they integrated the sensors in their sport elements to control the achievements of the sportsmen.